Hey there, and welcome. Today we're going to tackle a topic that can feel like a total black box if you're not a developer: software testing. Our goal here is super simple: make it make sense for absolutely everyone.
You know that feeling, right? You're sitting in a project update, and the team starts throwing around words like regression, APIs, and bugs. You're just nodding along, secretly hoping no one calls on you. It happens to the best of us, but we're going to fix that today.
So we are officially pulling back the curtain on one of the most critical parts of any tech project. We're going to decode software testing so you can walk into your next meeting feeling like you actually belong there.
To really get our heads around software testing, let's just forget about code for a second. Instead, think of it as something much simpler: a crucial safety check.
Really, at its heart, software testing is just like inspecting a brand new car. I mean, you would never drive it off the lot without being absolutely sure the brakes work and the engine actually starts, right? You want to find any problems before you're speeding down the highway. Well, testing does that exact same thing, but for software.
And just like that car inspection, this isn't some nerdy technical step. It has huge business value. So let's dig into why this safety check is such a game changer.
Okay, first off, it protects your company's reputation. A glitchy, buggy product can kill trust in an instant. Second, it saves a ton of money. Trust me, fixing an issue before launch is way cheaper than trying to fix it for thousands of angry users later. And finally, and this might be the most important one, it keeps your customers happy. A smooth, frustration-free experience is what makes people love your product and tell their friends about it.
So, what does this safety check actually involve? What are we looking for? Well, we can break it all down into a simple 4-point inspection. Think of it as the main checklist for pretty much any piece of software.
First up, functionality. This is the most basic question of all. Does the thing actually work? If you have a shopping app, can you add something to your cart and successfully pay for it? If you can't, the whole point of the app is broken.
Next is reliability. See, it's not enough for the software to work just one time. Does it work every time? Does it do it without crashing or freezing on you? A reliable app is like a reliable car. It starts up every single morning, no questions asked. Third, we have usability. And this is all about the user's experience. Is the software intuitive, or does it feel like you need to read a 100-page manual just to figure it out? You can have the most powerful app in the world, but if it's a pain to use, people just won't use it. It has to feel easy.
And our final checkpoint is performance. How fast is the software? Does it lag? Does it take forever to load? And what happens when tons of people try to use it all at once, like during a Black Friday sale? It's got to be fast, and it's got to be strong enough to handle the pressure.
Okay, with the fundamentals down, let's go back and tackle that jargon we talked about at the beginning. Think of this as your quick start translation guide for the most common tech terms you're going to hear.
You hear this one constantly. Oh, we found a bug, or we're working on a bug fix. But what in the world does that actually mean in plain English?
A bug, or a defect, is literally just a mistake in the computer code. A fantastic way to think about it is like a typo in a book. It's just an error that wasn't supposed to be there. Or even better, picture a recipe with a missing ingredient. The final dish might look okay, but it's going to taste wrong because something fundamental is missing. That's a bug.
Let's run through a few more of these. Regression testing. That's just checking that a new update didn't accidentally break something that used to work. It's like when a plumber fixes your kitchen sink, and then you double-check that the shower up still works. Integration testing. Make sure all the different parts are talking to each other correctly. Think about a restaurant. The waiter has to communicate with the kitchen so you get the right food. That waiter, by the way, is a great analogy for an API. It's just a messenger that takes your request to the system and brings back the response. And finally, user acceptance testing, or UAT. That's just a fancy way of saying we let real users test drive the software to see if they actually like it and if it works for them.
So now you get the concepts, you get the lingo, but how do you actually talk about all this stuff in a meeting without sounding like you're reading from a textbook? Our last section is all about that: effective communication.
It really boils down to a few simple do's and don'ts. Do, focus on the business impact. So instead of saying, the database query is failing, you say, this bug is preventing 10% of our users from checking out. See the difference? And use simple visuals, like a pass-fail chart. Now, what to avoid? Don't use heavy technical jargon like latency or stack trace. Nobody cares. And don't overcomplicate things. Give the simple, high-level summary first. You can always add more detail if someone asks. The goal is always clarity, not complexity. By keeping these simple analogies and rules in your back pocket, you can totally change how you show up in those technical discussions. You'll start asking smarter questions, you'll understand what's at stake, and you'll be able to contribute in a much more meaningful way. So the only real question left is this: what will your next project meeting sound like?